Tonight we're on page 3 of the Chapter 5 notes packet. We're picking up where we left off yesterday. We started talking about the discriminant. We got through our 4 examples, and we want to look at the chart on the bottom half of page 3. It says that the roots of a quadratic equation can be classified into 4 different types. They can be either real, rational, unequal, real, irrational, unequal, real, rational, and equal, or they can be imaginary, meaning they're not real at all. When the discriminant value, b squared minus 4ac, is greater than 0, meaning a positive value, and is a perfect square, your roots are real, rational, and unequal. How many x-intercepts of the graph? There are 2 x-intercepts. If the discriminant value is greater than 0 and not a perfect square, your roots are real, irrational. So if it's not a perfect square, your roots are irrational. If it is a perfect square, they are rational. Number of x-intercepts is 2. If the discriminant value equals 0, your roots are real, rational, and equal. So the key to remember is when the discriminant value comes out to be 0, your roots are going to be equal. And that would leave you with only 1 x-intercept on a graph. And if the discriminant value is less than 0, meaning negative, then your roots are not real, they're imaginary. And the graph of your parabola would not even intersect the x-axis, so there would be no x-intercepts. Remember, the graph of a quadratic equation is called a parabola, and the roots of a quadratic equation are located on the x-axis. We saw that back on page 1 of our notes. We had those 3 or 4 graphs that we sketched, and there we go. Going back to page 1. Here we had the 2 roots that were real, 2 real roots, 2 irrational roots, and then another 2 real roots. Next page, page 4. Each case of the discriminant tells us something about the location of the parabola on the xy plane and how many times it intersects the x-axis. So we are going to sketch, right? If your discriminant, if your b squared minus 4ac comes out to equal 0, then the number of x-intercepts is just 1. So we might have something that looks just like this. We would have a parabola that touches the x-axis at just 1 point. These roots would be real, rational, and equal. If your discriminant value is greater than 0 and a perfect square, you're going to have 2 x-intercepts. Your roots are going to be real, rational, and unequal. You've got 2 different roots, so they're unequal. If your parabola is greater than 0 and not a perfect square, you will have 2 x-intercepts, and your roots will be real, but irrational and unequal. And if your discriminant value is less than 0, meaning a negative value, the number of x-intercepts would be none, or 0. So we have a parabola that does not intersect the x-axis at all. Your roots are imaginary. You have to remember these 4 different types. Examples: determine the value of the discriminant and describe the roots of the equation. Okay, so for A, we have this quadratic equation. It's in standard form. I'll pull out the A, B, and C values. A is 2, B is -5, and C is 1. Now we're just focusing on the discriminant. That's it. Remember, the discriminant is B squared minus 4AC. So B squared, -5 squared, minus 4 times A is 2, and C is -5. -5 squared is 25. I have a double negative here. Well, let me correct that. That's not -5, that's 1. The C value was 1. Okay, so this is 25 minus 8, which is 17. So the discriminant is equal to 17. 17 is not a perfect square. So if it's not a perfect square, let's say if it's not perfect, it's not rational, it's irrational. Describing the roots, they would be real, irrational, and unequal. The number of x-intercepts, there would be 2. We want to do the same for B and C. Again, this is in standard form. The A value is 1, B value -10, and C value 25. So we're looking to plug in these values into B squared minus 4AC. -10 squared minus 4 times A is 1 times C is 25. 10 squared is 100. Subtract 4 times 1 times 25 is 100. So our discriminant value is 0. So our roots would be real, rational, and equal. When the discriminant value is 0, that's the case in the upper left-hand corner here. Your roots are real, rational, and equal. There's only one x-intercept. And C, it's in standard form. Pull out your A, B, and C values. Plug into B squared minus 4AC. -8 squared is 64. The double negative would be plus 4 times 3 times 3. 36. 64 plus 36 is 100. 100 is a perfect square, so your roots are going to be real, rational, and unequal. Number of x-intercepts, 2. More practice on the next page, the top of page 5. Again, as it says, try some of these on your own. Pause the video and try on your own. Directions are to determine the value of the discriminant and describe the type of roots as one of the following. 1, either real, rational, unequal. 2, real, irrational, unequal. 3, real, rational, equal. Or 4, imaginary. Okay? Now, keep in mind, real, rational, unequal. That's when it's a perfect square. Real, irrational, unequal. Irrational when it's not a perfect square. Real, rational, equal, keyword equal, that's when your discriminant value is going to be 0. And imaginary, that's the easiest one, I think. That's when it comes out to be negative, less than 0. Okay, so we're finding the discriminant value of each and then describing the type of roots it has. Okay, number 1, in standard form already. A is 1, B is -7, C is 4. Plugging into B squared minus 4AC, that's -7 squared minus 4 times 1 times 4. 49 subtract 16 is 33. So our discriminant value is 33. 33 is not a perfect square, so our roots would be real, irrational, and unequal. That would be choice 2. Number 2. A is 3, B is 4, and C is negative 4. So plugging in b squared minus 4ac, 4 squared minus 4 times a is 3 times c is negative 4. That's 16. That's a double negative there. So that's going to be plus 12 times 4, 48. 16 and 48 is 64. 64 is a perfect square. So that means your roots are going to be real, rational, and unequal. That would be option 1. Number 3, again, it's in standard form already. Pull out your values for A, B, and C. Then substituting into b squared minus 4ac, negative 8 squared minus 4 times A times C. 64. 3 negatives is going to result in minus, and that's 64. 64 minus 64 is 0. So our discriminant value is 0. And the roots will be real, rational, and equal. Option 3. Number 4. It's in standard form, our quadratic equation. Pull out the values for A, B, and C. Substitute them in for b squared minus 4ac. B squared, so negative 4 squared minus 4 times A times C. That's 16 minus 2060. 16 minus 60, negative 44. If our discriminant value is negative, the roots are imaginary. That's choice 4. Number 5. Again, it's in standard form. A is negative 3, B is 2, C is 7. Substituting in b squared minus 4ac. That's 4. Double negative is going to be plus 12 times 7, 84. So 84 and 80 and 4 is 88. 88 is not a perfect square. So our roots are going to be real, irrational. It's not perfect square, so it's not rational, irrational, and unequal. Option 2. Number 6, that's the first one that we'd have to put in standard form first. 2x squared minus 5 equals 0. So our a value is 2. B, there is no x term, so the coefficient of it would be 0. And c is negative 5. B squared minus 4ac. So 0 squared minus 4 times a times c. Double negative is going to be plus, so this is going to be 0 plus 40, which is 40. Our discriminant value is 40. That's not a perfect square. Not perfect. So not rational. It'd be irrational. Real, irrational, unequal. It's option 2 again. Okay, now more problems involving discriminant, but in the form of a word problem. It says here the roots of the equation ax squared plus 4x plus 2 equals 0 are real and equal when a is equal to. Keywords here are real and equal. Well, when are the roots equal? When the discriminant is equal to 0. When b squared minus 4ac is equal to 0. The roots of the equation are real and equal when the discriminant value is equal to 0. So let's take and substitute in. B is 4, so 4 squared minus 4 times A is A, and C is 2. All right. When does this equal 0? 16 minus 8A equals 0. Solve this for A. If I add 8A to both sides, I have 16 equals 8A. Divide by 8. So your A value is 2. So the roots of the equation are real and equal when A is equal to 2, which would be option 2. Number 2, the roots of x squared plus bx plus 3 equals 0 are real when b is equal to, well, our roots are real when the discriminant, when b squared minus 4ac is greater than or equal to 0, right? That's when our roots are real. In other words, it can't be less than 0. If it's less than 0, your roots are not real, they're imaginary. All right, well, let's substitute in and solve this inequality. A is 1, B is B, and C is 3. So B squared minus 4 times 1 times 3 has to be greater than or equal to 0. That's B squared minus 12 needs to be greater than or equal to 0. Now, B squared needs to be greater than or equal to 12. Well, now look at the options. If we take 0 and square it, is that greater than or equal to 12? So try our choices. Is 2 squared, which is 4, greater than or equal to 12? No. Is 3 squared, which is 9, greater than or equal to 12? No. Is 4 squared, which is 16, greater than or equal to 12? Yes. So the roots of the equation would be real if b is equal to 4. Number 3, the roots of x squared plus bx plus 2 equals 0 will be imaginary when b equals, okay, they'll be imaginary when the discriminant is less than 0. So when the discriminant is negative, when b squared minus 4ac is less than 0, the roots would be imaginary. And pull out the values for a, b, and c. A is 1, b is b, and c is 2. So b squared minus 4 times 1 times 2 would have to be less than 0. B squared minus 8 is less than 0. So b squared, adding 8 to both sides, b squared is less than 8. Again, try the options here. Is 1 squared, which is 1, less than 8? No. Plug in 7. Is 7 squared, which is 49, less than 8? No. Okay, hopefully you caught this. Is 1 less than 8? Yes, it is. So option 1, answer 1 is our choice here. Number 4, what is the positive value of m in the equation 4x squared plus mx plus 9 equals 0 that makes the roots equal? All right, so it's asking for the positive value of m in the equation that will make the roots equal. Keyword being equal, well, the roots will be equal when b squared minus 4ac comes out to equal 0. Again, pull out the values for a, b, and c. A is 4, b is m, and c is 9, and substitute the values into the equation. M squared minus 4 times 4 times 9 would have to equal 0. 16 times 9, that's 144. So m squared minus 144 would equal 0. Add 144 to both sides. M squared would equal 144. And then take the square root of both sides. So m would equal plus or minus 12. And we want the positive value, so the positive value would be 12, which is option 1. Okay, this will stop here for tonight and do 5 and 6 together in class. Or if you wanted, you could try them on your own, and we'll go over them in class tomorrow.